We are given a function that maps from real numbers to what? Real what? Numbers. Okay, let's start this with a function to make that clear. A function, remember I said, this is how you interpret this illustration. Function that maps from what? Real numbers to what? Real numbers. So let me state something where this represents what? Real numbers. So what are we told to do here? Okay, f is defined as f of x. We have our f to be defined as f of x equals to 2x plus what? 1. So we want to prove that this mapping is what? Injective. Now remember that for injective mapping, we stated that if x1 equals to x2, then f of x1 should equals f of what? X2. So for this, we have f of x1. Two cancels 2, we have what? X1 to be equals to what? X2. Now, since f of x1 equals to f of x2 gives us x1 to be equals to what? X2, we can go further and conclude that this mapping here, this function here, what is an what? Injective what? Mapping, or the mapping is an what? Injective what? Mapping. Since x1 equals to x2 such that f of x1 equals to f of x2, we can go further to conclude that this mapping is an what? Injective what? Mapping. Now let's take a look at another example. So we are still looking at mapping from real numbers to real numbers, but let's change our f of x to be something else. Therefore, since x1 equals to x2 such that f of x1 equals to what? F of x2, we can conclude that this what? Mapping is an what? Injective what? Mapping. Remember the condition for injective mapping: x1 equals to x2 such that f of x1 equals to what? F of x2, and vice versa. That is, if x1 does not equals to x2, f of x1 should not equals to what? F of what? X2. That is all what injective mapping is trying to make us understand. It's trying to help us understand that one element in your domain should only produce what? A single what? Image in your what? Co-domain. Now, at the beginning of this video, I explained that there are two methods for plotting our graph. The first one, which is what? Direct plotting, where you plot values of x and y, and the other can be with sketching graph to determine probably the intercept of x, intercept of y. Then went further and said you can also use it to determine the turning point, and we can also what? Use it to what? Determine what? Where the graph is what? Undefined. Now, to summarize the types of the function part, first of all, we started off with polynomial functions. We said polynomial functions are functions that can be represented in the form of summation ai, then x to the power of what? I, which I later was wrote out in this form, where we have what? A1x to the power of a1x to the power of 1 plus a subscript 2x to the power of 2 plus a subscript 3x to the power of 3. You keep on going until you get to the nth term, which is what? A subscript n x to the power of what? N. We went further to look at what? Trigonometric functions. We said trigonometric functions are functions that can be written in the form of what? F of x equals to what? A sine x plus what? B cos what? X. They have what? Trig what? Symbols in them. Now, exponential functions are functions that can be written in the form of what? F of x equals to a to the power of bx. You can have x to the power of 10. You can have exponential to the power of what? X. Those are all examples of what? Exponential what? Functions. We talked about logarithmic functions, which are functions that can be written in the form of y equals to f of x equals to what? Mean ax plus what? B. We also looked at periodic functions. We also talked about transcendental functions that don't take the form of any of the above here. We looked at periodic functions. There are functions in the form of what? F of x equals to what? F into bracket x plus L, where L represents the period of the function. And we also stated some rules on that periodic function. We said when it is odd, f of minus x should be equals to minus f of x, and when it is even, f of minus x should be equals to what? F of what? X. Now we went further to look at rational functions, and we said rational functions are functions that can be represented in the form of f of x equals to what? Ax plus b all over what? Cx plus what? D. We have a function x that maps from real number to real number. Now the first function f maps from x down to 9 minus x squared, and the section function maps from x to 1 all over what? 2x squared plus 1. So we'll be looking for the range of x and g, and also aside the range we'll be looking for, okay, this is f, We'll be looking for f inverse and also g what inverse. So let's start with the range. So for f now, let's pick from let's because at the end of the day, we have to what replace y with the value what x. We have to replace y with the value of what x. So that becomes g inverse, and that becomes what f what inverse. Hi, welcome back to Study Smart. Now for this video, I've written out some examples under limits and continuity that we can solve just to get a better grip or a better understanding of all we've been doing. Now, so far we've looked at L'Hopital's rule and we've looked at what sandwich theorem. Now, for this question now, we'll be trying to evaluate these questions and getting their limits without using L'Hopital's rule and sandwich theorem. Though you can use sandwich theorem, okay? Though you can use L'Hopital's rule for probably 2 or even all the questions, can use L'Hopital's rule from there. But we'll be looking at other procedures or other ways in which you can still evaluate your question and still get your answer. Now, note something under what limit. It's not necessarily use L'Hopital's rule or the sandwich theorem. Those are not the only 2 theorems you have for solving limits. The trick to limits is once you substitute the value of your x into the question or any variable you are given, and you are getting your denominator as 0, that is the function becomes undefined. You need to reevaluate that question or try to re-express it in a way that when you substitute the value of x into it, it does not give you is 0. That is all you need to do, just to keep evaluating until when you make a substitution and the denominator does not give you is 0. But in a situation where you've tried out all means of evaluating and the denominator still gives you is 0, in that situation you can conclude that the limit of that the function is discontinuous, it has no limits, or the function is undefined. So coming back to the questions on the board, let's start with question 1. So you see that it's not necessarily needful that we use L'Hopital's rule or sandwich theorem before we get the limit of our question. All you need to do is that when you know that you are getting is 0 as your denominator, you make sure that you keep re-evaluating and evaluating until you don't have is 0 as your denominator. But in a situation where you've tried all possible evaluating method and all possible expression, you are still getting is 0 as your denominator, you can conclude in that situation that the limit of that particular function does not exist or is discontinuous. So with this example, we've come to the end of this video. If you have any question regarding limits and continuity or regarding the question we solved, you are not clear about something, please do well to join them in the comment section. All questions will be attended to as soon as possible. We'll see shortly in the next video. Thank you. Bye. We are told to find the y, the x. So how do you go about this? First of all, write out our y. We have this to be sec cube of So the final answer for the derivative of y equals to sec cube tan square 3x will be 18 sec cube tan square 3x tan of tan square 3x. Okay, sorry, 6 should no longer be here. Since we've said 6 times 3 should give us 18. Tan of tan square 3x sec square 3x tan 3 x. We are still looking at application of differentiation, but another subtopic. We are looking at the maximum and minimum values of a function. Now the next example under this subtopic says, find the nature of the turning point of the function y equals to x cubed minus 2x squared
plus x plus what? 4. We are told to find the what? Nature of the turning point of y equals to what? X cubed minus 2x squared plus x plus what? 4. At the turning point, so we are told that the turning point that m equals to what? Is 0. That our turning point m equals to what? Is 0. So how do you go about solving this question? First of all, let's what? Get our what? Slope or gradient, which is what? Dy dx. You know that m equals to what? Dy the what? X. So we have dy dx here. Maximum what? Turning what? Point. Now note that if you are checking for your maximum and minimum values, this should always evaluate to the same what? Values, but one should be negative and the other should be what? Positive. If you are having two different values here, your question is your solving is what's wrong. So that should what? Notify you that you have to go through what you've done what again. So you should be having the same values here, just that one should be negative and one should be what? Positive. And the positive one is your minimum point, and the what? Negative one is your what? Maximum what? Point. So the next question, we have if x equals to p minus sine p and y equals to 1 minus what? Plus what? P. We are asked to find the area under the curve, the x-axis between what? P equals to 0 and p equals to what? Pi. Now we are still looking at the what? X what? Axis. Now since you are still looking at the x-axis, you still make use of this was first formula. Integral of a b y d what? X. Now what is x? X here equals to over 2 pi what? Squared what? Units. So the answer to this question is what? 3 all over 2 pi what? Squared what? Units.